Imagine a world where over 90% of all life vanished. Not from an asteroid, not from a supervolcano, not even from an ice age, but something far more mysterious. 250 million years ago, Earth was in chaos. Entire ecosystems collapsed. Oceans turned toxic. Skies darkened. And for a brief moment in geological time, life itself nearly ceased to exist. This wasn't just an extinction. It was the extinction, the most catastrophic event our planet has ever endured. But what really happened? What force could possibly wipe out nearly everything that walked, swam, or crawled? And how close did Earth come to becoming a barren, lifeless rock drifting silently through space? Tonight, we're diving deep, very deep, into a forgotten chapter of Earth's history, to uncover the terrifying truth behind the Permian extinction. What we find may challenge everything you thought you knew about life, death, and survival on this planet. Asterisk, long before the dinosaurs roamed the earth, before birds took flight, before flowers bloomed or grasses swayed in the wind. There was a world so strange, so alien, that if you stood within it, you might not recognize it as your own. This was Earth during the late Permian period, around 252 million years ago. It was a planet both familiar and utterly foreign, shaped by vast deserts, towering tree-like ferns, and bizarre, early reptiles that would never see the age of the dinosaurs. Let us go back to a time when the Earth was still young in its creative chaos. A time when life had conquered nearly every corner of the planet, and yet teetered unknowingly on the edge of absolute collapse. The face of the supercontinent, Pangaea from high above, the planet looked vastly different than it does today. All of Earth's land masses were joined together into one massive supercontinent called Pangaea, a name that means all Earth. It stretched from pole to pole, an immense expanse of land surrounded by a vast global ocean called Panthalassa. Pangaea's sheer size came with consequences. With so much land pushed into the interior, large parts of the continent were extremely dry, far from the moisture of ocean winds. Great deserts sprawled for hundreds of miles. Rainforests and wetlands existed, but they were scattered. Fragile pockets in an otherwise harsh environment. The climate was unpredictable. The seasons swung from scorching summers to freezing winters in many regions. This was a planet always on the edge, a place of beauty, but also of volatility. Life before the end, ancient ecosystems, despite these challenges. Life flourished. Forests of Glossopteris, an extinct group of seed ferns, dominated the southern continent. Their broad, flat leaves formed dense canopies, casting shadows over swampy undergrowth. In the tropics, strange plants like lycopods, sphenopsids, and gigantic horsetails towered overhead. There were no flowering plants, no grasses, not even bees or birds. Evolution had not yet written those chapters. Instead, insects ruled the skies. Enormous dragonflies with wingspans of nearly 70 centimeters, beetles that fed on decaying wood, and primitive cockroaches that had already endured millions of years of history. In the oceans, coral reefs had not yet appeared as we know them. Instead, sponge-like organisms, brachiopods, and ammonites filled the warm, shallow seas. Fish with armored plates swam slowly along the seafloor, and lurking in deeper waters were early sharks and nautiloids, silently cruising through the dark. Perhaps the most intriguing life forms of all were the creatures walking the land, prehistoric oddities, The reptiles of the Permian. This was the age of the synapsids, creatures that looked like reptiles but were more closely related to mammals than to modern lizards. Some of these animals had fur-like coverings. Some regulated their body temperature. They were precursors to us. Among them was Dimetrodon, often mistaken for a dinosaur, but actually much older. With its massive sail-like spine and reptilian body, it hunted in ancient swamps and forests. It was both predator and pioneer, part of a lineage that would one day lead to mammals. Other creatures like Lystrosaurus, a squat tusked herbivore with a pig-like snout, grazed across the plains in huge numbers. It was a survivor, one that would go on to become one of the few species to live through the coming extinction. There were creatures with beaks, with sprawling limbs, some with backward-bending knees, others with armored heads. Nature was experimenting wildly, brilliantly, with form and function. It was an age of evolutionary creativity, full of promise and potential, but beneath the surface, something was beginning to unravel. A delicate balance. Life in the late Permian had reached a precarious balance. Oxygen levels in the atmosphere were lower than they are today. Carbon dioxide was on the rise. Ocean currents were changing. The climate was warming slowly, then more rapidly. Species had adapted to a narrow set of conditions. Ecosystems were rich, but fragile. A disruption, even a small one, could echo across food chains and across continents. And that's exactly what was coming. Somewhere deep beneath the Earth's crust, pressure was building. In the far reaches of what is now Siberia, magma churned beneath ancient rock layers. A chain of events was beginning to unfold that would soon reshape life on Earth in the most devastating way imaginable. But here, in this chapter, we pause. We look at the calm before the storm, the last moments of an ancient world that would soon vanish forever. The final sunset. Imagine standing on the edge of a Permian swamp, the sky glowing with the red-orange hues of a setting sun. Giant ferns sway gently in the wind. Insects hum in the still air. A distant roar, maybe a Dimetrodon, echoes from the trees. The warm waters ripple with movement as an amphibian disappears beneath the surface. You wouldn't know it, but this moment, this peaceful, quiet scene, is one of Earth's last, before its greatest mass extinction, in just a few million years. A blink in geological time, over 90% of all species will be gone. Life will be reduced to shadows of its former self. The forests will burn. The oceans will die. The skies will darken. But for now, the world is still turning, and its story is just beginning. In the vast silence of deep time, Earth is always moving. Continents shift. Oceans open and close. Mountains rise and crumble. And sometimes, the world itself folds into something new, something massive. Over 250 million years ago, during the late Permian period, this transformation reached its peak. For the first and only time in human memory, and perhaps the last, all of Earth's continents joined together in a single, colossal landmass, Pangaea, a supercontinent, a unified Earth, but beneath its strength lay the seeds of disaster. What was Pangaea? Pangaea wasn't just a large continent. It was the continent, formed over hundreds of millions of years. It brought together ancient landmasses like Gondwana in the south and Laurasia in the north, smashing them into a single superstructure that stretched from the icy poles to the warm, humid equator. It was so large that it affected nearly every system on Earth, the atmosphere, the oceans, the climate, and even life itself. Along its interior, Far from the stabilizing effects of nearby seas, massive deserts formed. Rainfall became scarce. The land baked under harsh sunlight in the summer, then froze in long, dry winters. Unlike the lush, fragmented world of today, much of Pangaea was unforgiving, a continent that tested the limits of life. But how did this immense landform even come to be? The power beneath, plate tectonics at work. The Earth's crust is broken into enormous slabs, known as tectonic plates, floating like puzzle pieces atop the semi-molten mantle below. Over time, these plates drift. Sometimes they collide, sometimes they pull apart, and when they collide, continents are born. The formation of Pangaea was the result of countless collisions. Africa collided with North America, India drifted northward, Australia and Antarctica were once part of the same southern landmass. These movements were slow, just a few centimeters per year, but relentless. Over hundreds of millions of years, they shaped the planet like a sculptor with infinite patience. By 252 million years ago, those plates had finally formed a near-seamless land bridge across the globe. Earth, as a whole, had changed. Climate, chaos on a continental scale with one massive landmass dominating the planet. Earth's climate entered a period of extremes. Pangaea's size disrupted, atmospheric circulation, the way wind and weather move across the globe. Moisture that might once have brought rain to interior regions could no longer reach them. Instead, it stayed trapped along coastlines. This meant interior deserts stretched for thousands of kilometers. Seasonal temperatures fluctuated wildly. Polar regions were colder than ever, while equatorial zones scorched, and yet Earth was also warming. Deep ocean currents, crucial for regulating the planet's climate, were weakening. With fewer shallow seas and narrower continental shelves, much of the heat that should have been absorbed and cycled through the oceans stayed trapped in the atmosphere. Carbon dioxide levels rose, oxygen dropped, and the systems that supported life began to strain. The oceans struggled while Pangaea dominated the land. The rest of the Earth was covered by a single massive ocean, Panthalassa. This ocean was unimaginably vast, with no real modern comparison. But its size didn't mean safety. Panthalassa was deep and dark, and with fewer shallow seas. Marine life had fewer places to thrive. Coral reefs in their ancient early form were limited. Nutrient-rich upwellings became more rare. Oxygen levels began to dip. In parts of the ocean, anoxia, the complete absence of oxygen, took hold. Entire swaths of sea became dead zones for life in the water. This was a dangerous sign. For the planet, it was a warning. The rise of fire and desolation. With drying climates and expanding deserts, wildfires became more common. Ancient forests burned. Peat bogs dried and ignited. Even in the absence of human activity, Earth was no stranger to catastrophe. Fossil records from this time show massive charcoal layers, hinting at frequent and widespread fires. These fires released carbon dioxide, accelerating warming, and with fewer forests to pull carbon back out of the air, the planet's ability to regulate itself diminished even further. Meanwhile, the plants and animals that had once thrived in lush Permian forests were being pushed to the edges, clinging to rivers, coastlines, and cooler uplands. Many species had nowhere left to run. Life under pressure as the climate changed. Evolution responded, but not fast enough. Species had adapted to specific environments. Certain reptiles relied on lush vegetation. Marine organisms needed precise oxygen levels. Insects depended on humidity and stable temperatures. When those conditions changed, the ecosystems collapsed like dominoes. Some organisms survived by chance, others through resilience. But many could not keep up with the speed of planetary change. The Permian period became a slow motion unraveling of everything life had built for millions of years. And yet, the worst was still to come. Because deep below Siberia, the Earth was about to open. A tremble in the deep inner region we now call Siberia. Magma had begun rising from the Earth's mantle, pooling beneath the crust in massive chambers of molten rock. These weren't normal volcanic eruptions. This was something far more catastrophic, a large igneous province, a volcanic event on a planetary scale. Soon, vast cracks would split the surface. Rivers of lava would pour across thousands of kilometers. Gases, toxic, climate-altering gases, would spew into the atmosphere. The Siberian traps were forming, and with them, the final blow to an already fragile world. The calm before collapse at the edge of this chapter. We once again pause, because while Pangaea brought all land together, it also created the conditions for mass separation between the living and the dead, between what would endure and what would vanish. The supercontinent was both a marvel and a mistake, a natural wonder and a slow-motion trap. For now, life still clung on in the forests, in the rivers, in the warm shallows of Panthalassa. But the pressure was building, and in the next chapter, we witness what happens when a planet begins to break from within, and when extinction comes, not from the sky, but from the very depths of Earth itself. In the long silence of deep time, great changes do not always roar. Sometimes they whisper. Not all extinctions are sudden. Not all catastrophes explode from the heavens. Some begin slowly, invisibly, deep beneath the surface, in places no creature can see. This was the quiet beginning of Earth's darkest chapter, before the world collapsed in fire and death. The signs were already there. Small shifts, subtle declines, the unraveling of stability. The planet was changing, and life, though still flourishing in pockets, was about to face a test it had never encountered before, an overheating world by the late Permian period. Global temperatures were rising, and not by small degrees. This warming was different from seasonal shifts or natural variations. It was relentless, gradual at first, then faster. The fossil record shows stressed vegetation, shrinking ecosystems, and migrating species pushed out of their historical ranges. In what is now modern-day China, fossilized ferns show signs of UV radiation damage, suggesting the ozone layer itself may have been breaking down. In Australia and South Africa, pollen grains abruptly disappear from sediment layers, replaced by charcoal and soot. Forests, once thick and thriving, began to die, and without forests, the world had no filter, no shield, no buffer. The oceans begin to suffocate inland. Life was drying up. But in the oceans, it was drowning. The massive supercontinent Pangaea had dramatically altered the ocean's circulation systems. As the shape of the world changed, deep ocean currents weakened. Waters warmed. Stratification took hold, where warm water sat still above cooler layers, preventing oxygen from reaching the depths. The result, anoxic oceans, bodies of water starved of oxygen, where most marine life couldn't survive. Corals died. Sponges disappeared. Entire marine ecosystems began to crash, layer by layer. Then, something even more dangerous began to brew. Hydrogen sulfide, produced by bacteria thriving in these oxygen-deprived waters. Hs is a toxic gas, and as it accumulated, it began to rise, first into the water column, and then, possibly, into the atmosphere. The very air may have become poisoned. Signs in the fossils tell stories, and in the late Permian, they tell one of panic suddenly. Species that had survived for millions of years begin to vanish. Brachiopods, which had flourished in Paleozoic seas, start to disappear. Trilobites, once among Earth's most successful animals, go extinct entirely. Reefs, made of ancient sponge-like organisms, vanish, even ammonoids. Distant relatives of today's squid and octopuses show sudden gaps in their fossil records, and yet, it's not just the loss that's alarming, it's how fast it happens. In the fossil layers, diversity plummets in what amounts to just a few thousand years, a blink. Geologically speaking, entire ecosystems collapse. All at once, tectonic pressure, Siberia begins to stir. The heart of this story lies Siberia, a cold, remote expanse of Earth that once held a devastating secret. Here, in the final moments of the Permian, the planet began to erupt. Not with one volcano, not with dozens, but with thousands, stretching across over 7 million square kilometers. We call them the Siberian Traps, one of the largest volcanic events in Earth's entire history. Lava did not explode in cones, but instead oozed from deep fissures in the Earth's crust, flooding the surface in waves of molten rock. These eruptions lasted for hundreds of thousands of years, releasing enormous quantities of carbon dioxide, CO, methane chains, sulfur dioxide, and possibly toxic metals like mercury and lead. Each of these gases had a role to play in Earth's unraveling. Methane trapped heat, accelerating global warming. Sulfur dioxide created acid rain, killing plants and acidifying oceans. Toxic metals poisoned soil and water systems. The Earth had cracked open, and it would not heal for millions of years. The air turns deadly as the skies filled with volcanic gases. Sunlight dimmed. Global temperatures first dropped briefly from the ash clouds. But when the ash settled, what came next was worse. A greenhouse Earth. Temperatures surged. Oceans continued warming. The ice caps melted, and then came the sulfur, forming acid rain that scorched forests, dissolved freshwater habitats, and stripped the land bare. In this era, the very air may have become lethal, not just to plants and animals, but to entire biomes. Some scientists believe hydrogen sulfide gas, bubbling from anoxic oceans, combined with volcanic emissions to make parts of Earth's surface effectively unbreathable. Insects declined dramatically. Amphibians vanished. Plants struggled to reproduce. The atmosphere, once the cradle of life, had become a silent killer. Could life sense it was ending? There's no fossil record for fear, but one can imagine, in these final decades and centuries of the Permian, a world out of sync, animals unable to find food, plants blooming at the wrong times, waters empty where life once teemed, fires racing across forests once soaked with life. Species fought to adapt. Some migrated, some shrank in size, others vanished without a trace. For the first time, mass extinction wasn't coming from a meteor or a sudden ice age. It was rising slowly, from the very systems that had once supported life, and there was no place to hide. The collapse accelerates by now. The decline was no longer slow. Ecosystems that had taken millions of years to build were dismantled in mere thousands. It is estimated that 96% of all marine species went extinct. Up to 70% of land vertebrate species vanished. Nearly all insect orders suffered massive losses. This was not just a mass extinction. It was the mass extinction, the greatest biological crisis Earth has ever known. A planet in freefall, and yet life would survive. Just barely. But in the next chapter, we will witness how the catastrophe unfolded at full scale, a moment of profound death, followed by the long, painful struggle for life to return. There are moments in the history of Earth when life pauses, when the forests go quiet, when the oceans turn still, when evolution, for a time, forgets how to move forward. Roughly 252 million years ago, such a moment arrived, and it did not pass quickly. This was not the slow decline of a dying world. It was an abrupt rupture, a turning point so severe that it reset the clock of life itself. We call it the Great Dying, the Permian Triassic Extinction event. But those are just words. The reality was more than extinction. It was global collapse. How it began as the Siberian traps continued to erupt. For tens of thousands of years, without pause, the Earth's systems began to break one by one. Carbon dioxide levels spiked. The planet heated rapidly. The oceans became more acidic, less oxygenated, and darker by the day. Volcanic gases, once confined to the skies above Siberia, had now spread across the entire globe. Rainforests, once teeming with amphibians and insects, shriveled and burned. Rivers dried into cracked ravines. Coastal wetlands turned to lifeless swamps. Species had adapted to many dangers before, but not this. Not all of it at once. A toxic recipe for extinction. What made the Great Dying so catastrophic wasn't a single cause, but the perfect storm of many. Here's what scientists believe combined to create the worst extinction in history. Massive volcanism, the Siberian traps, released more lava than any other known eruption on Earth. These flows emitted trillions of tons of CO and methane, warming the planet dramatically. Global warming temperatures rose by as much as 8 degrees Celsius, 14 degrees Fahrenheit in some regions. Insects lost the ability to reproduce. Amphibians dried out. Coral reefs bleached and crumbled. Ocean anoxia with warm, still oceans. Oxygen levels plummeted. Whole sections of ocean became dead zones, where not even bacteria could thrive. Hydrogen sulfide release. Some scientists theorize that purple sulfur, bacteria thriving in oxic waters, released H's gas into the atmosphere, poisoning land dwellers and destroying the ozone layer. Acid rain, sulfur dioxide from the volcanoes turned into sulfuric acid in the skies, falling as acid rain that killed plants, eroded rocks, and poisoned freshwater supplies. Methane bursts from permafrost as the world warmed. Frozen methane clathrates beneath the sea floor may have melted, releasing sudden pulses of supercharged greenhouse gas, a feedback loop that worsened everything. This was not one disaster. It was many, overlapping, accelerating, feeding into one another, and as they combined, life unraveled at a speed never before seen. Extinction in the oceans, in the seas. The devastation was immediate. For over 300 million years, the oceans had been a sanctuary filled with corals, trilobites, ammonites, brachiopods, sea lilies, and armored fish. Now they were death traps. Warm water strangled marine respiration. Acidification dissolved shells and skeletons. Coral reefs, primitive but essential, disappeared entirely. Surface plankton, the base of the marine food chain, collapsed among the victims. Trilobites, survivors of multiple previous extinctions, now gone forever. Brachiopods once dominant, now shattered into obscurity. Ammonoids reduced to just a handful of surviving species. Reef-building organisms nearly all wiped out. In some regions, up to 96% of marine species vanished. Entire ecosystems gone as if erased overnight. Extinction on land. Life on land fared no better. Forests vanished. Rivers dried. Temperatures spiked to levels unlivable for most amphibians, reptiles, and insects. Among the hardest hit, large amphibians, once dominant predators in freshwater systems, vanished almost entirely. Reptilian lineages, especially early mammal-like reptiles, suffered severe collapses. Insects, one of the few times in history their diversity fell drastically. Even the hardiest lifeforms, those that survived previous droughts, ice ages, and volcanic events, began to fail. Fossil evidence from South Africa's Karoo Basin and Russia's Ural Mountains shows a stunning decline in vertebrate diversity in the final 100,000 years of the Permian. It is as if life tried to persist, but the Earth simply stopped supporting it. How bad was it, really? The numbers are staggering. Over 90% of all species on Earth went extinct. Entire ecosystems, both marine and terrestrial, were dismantled. Recovery took 5 to 10 million years. This wasn't just a pruning of life's tree. It was nearly a reset. From complex webs of diversity, the planet was reduced to a few surviving lineages. Lonely, scattered, struggling to repopulate a broken world. And yet, life did go on. The survivors, fragile sparks in the dark among the ruins, a few creatures held on. Lystrosaurus, a pig-sized tusked herbivore, somehow adapted to drought, heat, and low oxygen, and came to dominate the early Triassic. Cynodonts, small, warm-blooded ancestors of mammals, endured in the shadows. Archosaurs, early relatives of dinosaurs and crocodiles, quietly rose in the oceans. A few ammonoids, fish, and marine reptiles began to reappear. These survivors were the seeds of the next great wave of evolution, though they had no way of knowing it. For now, they were just ghosts walking through a dead world. The planet after the famine, the wake of the great dying, Earth was unfamiliar. No forests, no reefs, few rivers. A dry, scorched landscape with thin air and silent skies. Rain came less often. The soil was weak and lifeless. Temperatures swung wildly between seasons. But even in this damaged state, Earth began to breathe again. Very slowly, ferns returned first, spreading spores on the wind. Then mosses. Then the first scattered trees. In the oceans, algae began to regrow. Simple ecosystems took shape. It would be millions of years before true complexity returned, but the darkness had passed. A turning point in evolution. Why does the great dying matter? Because it changed the entire direction of life on Earth. Without it, dinosaurs may never have risen. Mammals may have never evolved. Humans, if they ever appeared, would have lived in a world filled with ancient reptiles, brachiopods, and trilobits. In its violence, the great dying cleared the stage for something new, not better, not worse, just different. This is the paradox of extinction. It is both an end and a beginning. In the next chapter, we explore how life slowly emerged from the ruins, and how the age of the dinosaurs was born, not from dominance, but from survival. When the fires stopped, when the skies cleared, when the ash fell silent, there was nothing, no forests, no reefs, no songs of birds or hums of insects, just silence and time. The Permian Triassic extinction had erased more than species. It had erased memory, the old rhythms of life, the ancient systems that had taken hundreds of millions of years to build. All gone, and yet, from the bones of that devastation, something new began to stir. This is the story of what came after the world reborn, and the creatures that would reshape it. A dead world begins again in the early Triassic period. Earth was a planet of emptiness. The once thriving rainforests were replaced with dry, dusty landscapes. Global temperatures remained dangerously high, sometimes reaching above 50 degrees Celsius, 122 degrees Fahrenheit in equatorial zones. The oceans were still unstable, reeking with the remnants of anoxia and hydrogen sulfide. But the volcanoes were quiet now. The skies had begun to clear, and in the stillness, the survivors emerged. The sole survivors. The Permian Triassic extinction had been total, but not absolute. A few lineages survived the collapse, clinging to life in the shallow corners of Earth's broken ecosystems. Among them, Lystrosaurus, a squat, tusked herbivore. It survived by being adaptable, omnivorous, and extremely efficient at digging and scavenging. In some fossil beds, 90% of all vertebrate remains belong to Lystrosaurus, cynodonts, small, fur-covered, warm-blooded creatures. These distant ancestors of mammals likely survived due to their ability to regulate body temperature and live in burrows during extreme conditions. Temnospondyl amphibians, large semi-aquatic creatures that managed to cling on near scattered freshwater habitats. Protozoutids and early archosaurs, small, nimble reptiles that would eventually give rise to crocodiles and dinosaurs. These were not majestic animals. They were not dominant or even thriving. They were survivors, tough, adaptable, and lucky. That was all it took. The green returns before animals could reclaim the land. Plants had to return. The earliest regrowth came not from trees, but from ferns and mosses. Hardy, fast-spreading, and requiring little soil. They were perfectly adapted to a wounded planet. These were known as disaster taxa, species that thrive in post-catastrophe environments. Their spores filled the air, coating the barren ground in green dot. Then came conifers, cycads, and ginkgos, slow-growing, deep-rooted plants that would dominate the Triassic forests. The oxygen levels were still low, the climate still extreme, but life had found a way forward. Enter the Archosaursimon, the survivors. One group began to rise faster than all the others. They were small, they were fast, they were different. They were archosaurs, the ruling reptiles. From this lineage would come crocodilians, pterosaurs, flying reptiles, and eventually dinosaurs. The archosaurs thrived where others faltered. Their hips allowed more upright walking, making them faster. Their lungs were more efficient. Some were likely warm-blooded, allowing them to survive temperature swings. In the new world of the Triassic, where competition was minimal and resources slowly rebounding, these traits gave archosaurs an edge. For now, they were just one of many. But soon, they would become the dominant life forms on Earth. The oceans rebuild, though marine life had been devastated. The oceans slowly began to repopulate. Bivalves like clams and oysters appeared. Gastropods, snails, and slugs began to diversify. Ammonoids, reduced to a few species, bounced back spectacularly, and a new group entered the seas: marine reptiles. These included nothosaurs, long-necked swimmers with sharp teeth; ichthyosaurs, dolphin-like reptiles that would eventually dominate the seas; Fish also diversified, including early ray-fin species that would eventually give rise to the fish we know today. It would take tens of millions of years for true coral reefs to return, but the oceans were no longer dead. Climate, still a killer, though life was recovering. It was not easy. The Triassic climate remained unstable, with long dry seasons, erratic monsoons, and continued volcanic activity. There were at least 2 mini-extinction events during the early and middle Triassic, reminders that the Earth was still healing. Oxygen remained lower than pre-extinction levels. Carbon dioxide was still dangerously high, and the atmosphere continued to warm. But each cycle of collapse was slightly less severe, each regrowth slightly more successful. It was a slow, stuttering march toward stability. Evolution accelerates in this vacuum of predators and competitors. Evolution surged with ecosystems empty and niches wide open. Species could diversify rapidly. This is called adaptive radiation, and it's one of the reasons why mass extinctions are often followed by evolutionary explosions. In the Triassic, herbivores became larger and more specialized. Carnivores evolved sharper teeth, faster legs, better lungs. Body plans shifted. Longer necks, upright stances, armored skins, and one group, still small and overlooked, began to experiment with size, speed, and structure. They were called dinosaurs. By the end of the Triassic, they were no longer survivors. They were rulers. The legacy of the Great Dying. The Great Dying was the worst catastrophe in the history of life on Earth. But it was also the beginning of the Mesozoic era, the age of reptiles. Without it, dinosaurs may never have risen. Mammals might have remained small, burrowing creatures. The structure of today's ecosystems would look entirely different. It reminds us of a profound truth. Sometimes, destruction makes way for creation. Sometimes, the end of one world is the birth of another. And in the next chapter, the creatures of this new world will rise into giants, hunters, flyers, and titans. How the forgotten became kings in the beginning. Dinosaurs were nothing special. They weren't the towering beasts we picture today. They didn't rule the world. They didn't even stand out. They were small, two-legged, fast, light. They crept through forests of ferns, hid in shadows, ate insects, small lizards, or early plants. But the world was changing, and in the quiet spaces left by extinction, something ancient was awakening. Over the next 30 million years, these humble creatures would evolve, spread, and rise, not through dominance, but through resilience. This is how dinosaurs inherited the Earth, a new kind of reptile. To understand the rise of dinosaurs, we must go back to their beginning. The earliest dinosaurs evolved in the late Triassic, around 230 million years ago, in what is now South America. Fossils from Argentina and Brazil tell us they were small, often less than 2 meters long, bipedal, walked on 2 legs, lightweight and agile, carnivorous or omnivorous. Some of the earliest known species include Eoraptor, a swift, 2-legged predator, likely one of the very first dinosaurs. Herrerasaurus, larger, with strong jaws and sharp claws. Saturnalia, a long-necked, nimble creature, hinting at future herbivores. These animals weren't dominant, they were just different, and that difference would shape the next 150 million years. What made dinosaurs special? What set dinosaurs apart from the other reptiles of their time? Several small but powerful evolutionary changes. Upright posture. Dinosaurs stood with legs directly beneath their bodies. Unlike sprawling lizards, this made them faster, more efficient movers. Efficient lungs, their breathing system, possibly inherited from their archosaur ancestors, was more efficient, allowing for better endurance. Hollow bones. Many dinosaurs had light hollow bones, helping with speed, balance, and eventually flight. Rapid growth. Fossilized bones show signs of fast growth, a major advantage in a world still recovering from extinction. They weren't just lucky, they were built for change. Earth in the Triassic. One continent, one world at this time. Earth's continents were fused into one giant landmass, Pangaea, from pole to pole. Dinosaurs could roam freely across massive deserts, shallow coasts, volcanic plains, and fern-filled valleys. The climate was harsh, hot, dry interiors, monsoonal storms on coasts, periodic droughts, and wildfires, but dinosaurs adapted quickly. They spread across Pangaea, diversifying with the environments. Different groups emerged: theropods, bipedal, carnivores, like Coelophysis, ancestors of T-Rex, and birds, sauropodomorphs, long-necked herbivores, early ancestors of giants, like Brachiosaurus, ornithischians, small, beaked plant-eaters, who would one day evolve into horned and armored dinosaurs. Each new species filled a niche. Each was a step toward something greater. The other contenders, dinosaurs, didn't rise alone. They competed during the Triassic. Other powerful reptiles also emerged: Rhesuchians, crocodile-like predators with massive jaws; etosaurs, armored, herbivorous reptiles; phytosaurs, long-snouted aquatic hunters, similar to crocodiles. For millions of years, these groups ruled different ecosystems. In fact, dinosaurs were still secondary players, fast and clever, but not yet dominant. What changed everything was another extinction. The end of the Triassic, another mass extinction around 201 million years ago. Earth faced yet another crisis. Massive volcanic eruptions in the central Atlantic. Magmatic province camp released enormous volumes of carbon dioxide and sulfur into the atmosphere. Oceans acidified again, temperatures spiked, acid rain scoured the land. Many major reptile groups, including most early crocodile relatives and large amphibians, died out, but dinosaurs survived. Why? Some theories suggest their fast growth and high metabolism made them more adaptable. Their upright stance helped them handle heat. Their eggs and nesting habits allowed for faster reproduction, whatever the reason. When the dust settled, the other giants were gone, and the age of dinosaurs had truly begun. Rulers of the Jurassic with their competitors gone. Dinosaurs exploded in diversity. The Jurassic period, starting around 201 million years ago, was a golden age for dinosaur evolution. In this era, sauropods grew into massive, long-necked giants like Diplodocus and Brachiosaurus. Theropods evolved into larger and more complex hunters, including Allosaurus stegosaurs, emerged with armored backs and spiked tails. Forests of conifers, ferns, and ginkgos covered the land in the skies. The first flying reptiles, pterosaurs, soared, and in the shadows. Tiny early mammals began their quiet story. Dinosaurs now filled every role. Predators, grazers, scavengers, defenders. They were no longer survivors, they were sovereigns. The gift of time. Why did dinosaurs become so successful? One answer is time. From the end of the Triassic to the end of the Cretaceous, dinosaurs ruled for over 160 million years. For comparison, humans have been around for only about 300,000 years. Dinosaurs ruled for over 500 times longer that time, allowed them to grow into massive sizes, develop feathers and wings spread across every continent, shape ecosystems that would echo into the future. They were not just animals, they were the architects of their world. The feathered sea dinosaurs evolved. Some began to change in unexpected ways. Their bones became lighter, their bodies warmer, their arms turned to wings, and their scales to feathers. Yes, feathers. The first feathered dinosaurs likely didn't fly. Their feathers were for insulation, display, or brooding eggs. But over time, this innovation would lead to something miraculous. By the end of the Jurassic, creatures like Archaeopteryx began to blur the line between dinosaur and bird. It would take millions more years for true birds to evolve, but the blueprint was already written. The dinosaurs were becoming something else, from forgotten to forever. The rise of the dinosaurs wasn't a story of dominance from the start. It was a story of opportunity, adaptation, and survival. Born from extinction, forged in heat and drought, sharpened by competition, and crowned by resilience, they took the quiet spaces left behind by disaster and filled them with thunder. In the next chapter, we explore the golden age of the dinosaurs. When the land trembled beneath giants, the skies filled with wings, and the earth belonged to the most spectacular creatures it has ever known. Would you like me to continue with Chapter 7? The giants walked dinosaurs at their peak. When the world trembled beneath their feet, by the time the sun rose over the middle of the Jurassic period, Earth had become a very different world. The land no longer lay quiet. It thundered with each step of the giants. The ground shook. Forests parted for their towering forms. Rivers curved around their vast herds. Even the skies above had to make way. This was the golden age of dinosaurs, an age of immensity, of diversity, of balance. Predators and prey, flyers and grazers, horns and claws and beaks and feathers. In this chapter, we explore the peak of dinosaur evolution, an Earth teeming with life, ruled by beings unlike anything before or since, a world divided and blooming as the Jurassic period turned into the Cretaceous. About 145 million years ago, the supercontinent Pangaea had begun to break apart. New oceans opened, islands formed, climate zones diversified. The Earth was humid and warm, but more complex. Lush coastlines and inland seas, expanding forests of conifers, ginkgos, and newly emerging flowering plants, vast river plains, perfect for herding giants. This new world offered new opportunities, and dinosaurs filled every one of them. The titans of the earth, sauropods. No creatures before or since have matched the sheer size of the sauropods. They were as long as 30 meters, 100 feet, as heavy as 10 elephants, with necks like cranes and tails like whips. Examples: Argentinosaurus, possibly the largest land animal to ever live; Patagotitan, a mountain of muscle and bone from South America; Diplodocus and Apatosaurus, long, low giants of North America. These creatures traveled in herds, migrating slowly through ancient floodplains. Their long necks allowed them to sweep wide areas of vegetation without moving far. They had tiny heads, small brains, but massive bodies. They were not smart. They didn't need to be. Their size alone kept them safe. Few predators dared challenge. A full-grown sauropod, the kings of the hunt, theropods were. There were giants. There were hunters. The theropods, bipedal, carnivores, evolved into some of the most skilled and terrifying predators the world has ever seen. In the Jurassic, Allosaurus reigned in North America, Ceratosaurus hunted with horned snouts and blade-like teeth. Packs of smaller theropods, like Coelophysis, moved swiftly and struck fast. But the true kings came in the Cretaceous. Tyrannosaurus rex, the most famous predator of all time. Spinosaurus, a massive crocodile-like hunter adapted for rivers and lakes. Giganotosaurus, South America's answer to T-Rex. Each was a product of its environment. Fine-tuned by evolution, keen senses, powerful jaws, fast-growth feathers. In many smaller species, they were terrifying. But they were only one part of the balance. Defense by design. The armored and horned herbivores evolved their own astonishing defenses. Ankylosaurs, low to the ground, covered in bony armor, armed with massive club tails, walking tanks. Stegosaurs, huge plates along their backs, spiked tails. Thagomisers, small brains, but fearsome defense. Ceratopsians, like Triceratops, shielded skulls. Forward-pointing horns, lived in herds, could charge like rhinoceroses, had evolved. Not just to eat, but to survive. They didn't need to run. They could stand their ground. Feathers, flight, and the first birds long before T-Rex roared. Smaller theropods were experimenting with feathers. These feathers were not just for flight. They served many purposes. Insulation to stay, warm display for attracting mates, or warning rivals brooding to keep eggs warm eventually. Some of these feathered dinosaurs took to the air. Archaeopteryx, the first known bird, with both feathers and teeth. Microraptor, a four-winged glider from the forests of China. Confucius ornis, beaked and feathered, with long tail plumes. Flight was born not in one moment, but over millions of years, through countless tiny changes. From the dinosaurs came the birds. And through birds, dinosaurs live on even now. The seas of the dinosaurs, while dinosaurs ruled the land. Other giants ruled the seas. Marine reptiles, such as plesiosaurs, with long necks and paddle-like limbs. Mosasaurs, huge, snake-like. Predators of the late Cretaceous. Ichthyosaurs, dolphin-shaped reptiles with enormous eyes. They were not dinosaurs, but they were their cousins. They hunted fish, ammonites, and even each other. And the oceans teemed with life. Coral reefs, giant sea turtles, sharks and rays, cephalopods like ammonites and belemnites. It was a blue world, as alive and dangerous as the land. Skies, filled with shadows. Above it all soared the pterosaurs, flying reptiles who ruled the air. They came in all shapes and sizes, some as small as sparrows, others like Quetzalcoatlus, with a wingspan over 10 meters, 33 feet, taller than a giraffe. Pterosaurs were not birds. They evolved flight separately, with wings of skin stretched over long fingers. Some dove for fish, some walked on all fours across beaches, some soared across continents on thermal winds. They were the first true masters of the sky, a fragile balance. For tens of millions of years, this world of giants remained stable. Herbivores and carnivores kept each other in check. Forests regenerated, rivers shifted, and dinosaurs followed. There were droughts. There were volcanoes. There were local disasters, but the ecosystems bounced back, stronger, richer, more complex. From the forests of North America, to the plains of Africa, to the river deltas of Asia, dinosaurs shaped every inch of the earth. This was their time, and they made the most of it. The sound of a living earth, imagine it now, as you close your eyes. The low, rhythmic thuds of sauropod feet marching through mud, the rustle of ferns as a horned triceratops grazes near the riverbank, the haunting cries of pterosaurs circling in the fading light, the distant roar of a tyrannosaur echoing over the hills and the flutter of wings as a feathered raptor disappears into the undergrowth. This was a world alive in every sense, vast, vibrant, balanced, and yet that balance would not last in the next chapter. We explore how it all came to an end, and how one final, unexpected catastrophe brought the reign of the dinosaurs crashing down. The sky fell, and the world burned for over 160 million years. Dinosaurs had ruled the earth. They survived mass extinctions, shifting continents, raging volcanoes, and drastic climate swings. They adapted, evolved, diversified. They filled every role. They were everywhere. And then, in a single day, it all changed. A flash in the sky, a sound louder than thunder, a wave of heat, a night that lasted for months. This is the story of the end, not just of dinosaurs, but of an entire chapter in Earth's deep history. The world before the fall before the impact. Earth was thriving. It was the late Cretaceous, around 66 million years ago. The continents had nearly reached their modern shapes. Lush forests spread across the land. Shallow seas divided North America in two. Dinosaurs were everywhere. Tyrannosaurus rex stalked the forests of western North America. Triceratops herds grazed the plains, and closaurs armored themselves against predators. Hadrosaurs, duck-billed dinosaurs, lived in massive herds, some able to vocalize across long distances. Above them, pterosaurs soared. Below them, small mammals scurried in the underbrush. In the trees, feathered dinosaurs perched, some resembling early birds. It was a stable world, balanced, ancient, familiar, until the sky tore open. The impact, a moment that changed everything. It began with a light in the sky, a chunk of space rock, over 10 kilometers wide, traveling faster than a bullet, entered Earth's atmosphere. It struck near what is now the Yucatan Peninsula in Mexico. The impact released energy equal to 10 billion atomic bombs. In an instant, a crater over 150 kilometers wide was blasted into the earth. Rock vaporized into plasma. Firestorms ignited across thousands of kilometers. A shockwave circled the globe. Megatsunamis swept over coastlines. But the worst was still to come. The aftermath, darkness and death within hours. Millions of tons of sulfur and soot rose into the sky. A thick cloud covered the planet, blocking the sun. Temperatures plummeted. Photosynthesis stopped. Plants died. Herbivores starved. And then the predators. It wasn't just one disaster. It was a chain reaction, slow, relentless, and merciless. For months, the earth stayed dark, then cold, then dry. Fires raged. Ash rained down. An acidified rain scorched the soil. Nearly 75% of all species on Earth vanished. The age of dinosaurs was over. What exactly happened? Scientists have pieced together the extinction from evidence all over the world. A thin layer of clay, rich in iridium, a metal rare on Earth, but common in asteroids, marks the boundary between the Cretaceous and the Paleogene periods. The famous KPG, boundary-shocked quartz and tektites, minerals formed under intense pressure and heat, are found across continents in the Gulf of Mexico. The buried Chicxulub crater holds the scar of the impact itself. Other events may have worsened the crisis. Volcanic eruptions in India, the Deccan Traps, released massive greenhouse gases. Sea levels dropped, altering coastlines and habitats. Climate variability was already stressing ecosystems, but the asteroid was the final blow. A perfect storm, a planetary-setting catastrophe. Who survived, and why? Not everything died. Some creatures endured. But why? Here's what we know. Small animals had better chances. Large dinosaurs required huge amounts of food. When plants died, so did the herbivores, and then their predators. Burrowing helped animals that lived underground, like some mammals and amphibians, were shielded from heat and debris. Cold-blooded species recovered faster. Reptiles, like crocodiles and turtles, with low metabolic needs, survived the famine better. Omnivores had an edge. Early birds and mammals that could eat a variety of foods, seeds, insects. Carrion had more options when ecosystems collapsed. Aquatic life fared slightly better, while many marine species died. Others, like some fish and sharks, found refuge in deeper waters. But the great, lumbering dinosaurs, the ones that ruled the land, could not adapt fast enough. The legacy lives on, but not all dinosaurs went extinct. One lineage survived, the feathered, flying descendants of small theropod. Incredibly, those survivors evolved into what we now call birds. The robin in your garden, the eagle in the sky, the hummingbird at the feeder. The penguin on a frozen shore reach is a living dinosaur, a whisper from a lost world. They carry the legacy of Tyrannosaurus and Velociraptor in their bones and blood. The last dinosaurs. We don't know what the final day looked like for the last known avian dinosaurs, but we can imagine a herd of Triceratops, huddled in ash-choked valleys, a lone T-Rex, weakened and starving, stalking through a scorched forest. Small dinosaurs, like Trudon, hiding in burrows or under ferns as fire blazed across the sky. They didn't know they were witnessing the end of an era. They only knew the sun didn't rise. The trees didn't bloom. The world had turned quiet, too quiet. And then silence. Extinction and opportunity. From the ashes of disaster came new life. With dinosaurs gone, mammals began to rise, small, warm-blooded, adaptable eaters of seeds, fruit, and insects, quiet survivors of a violent past. They evolved quickly. Rodents, primates, hoofed animals, whales, and bats, eventually humans. But it took time, tens of millions of years. We are newcomers in a world shaped by giants, dinosaurs, ruled for over 160 million years. Humans have been here for less than 1 million. We walk among their bones. We fly with their wings. We dig through the layers of time, looking for meaning in their extinction and our survival. A quiet end, a living echo now, as you rest. Imagine the final breath of a once mighty world, the last footstep of a titanosaur, the final screech of a pterosaur fading into smoke, a single feather. Drifting down through the ash-filled air, the earth turned. The stars blinked above, and a chapter closed, but not forgotten. Dinosaurs are not lost to time. They are part of it, part of us. In the next chapter, we'll journey through the fossil record, how these incredible creatures were discovered, misunderstood, and finally revealed to the world beneath our feet. The Earth remembers everything long after the last dinosaur took its final breath, long after forests regrew and oceans settled, long after mammals rose and humans walked upright. They waited, beneath layers of ash, clay, and time. The bones of giants slept, unmoving, untouched, undisturbed. The Earth had hidden its ancient story in stone. And for most of human history, we had no idea it was there. This is the story of how we discovered the dinosaurs, of curiosity, confusion, wonder, and the people who first asked, "What are these bones?" Before dinosaurs had a name thousands of years ago, people across the world discovered giant bones buried in hillsides, caves, and deserts. But without modern science, what could they think? To the ancient Greeks, enormous bones found in caves were said to belong to giants or titans, mythical creatures from their legends. In China, dragon bones were ground into medicine. In Native American stories, fossils became traces of thunderbirds or great beasts lost to time. In medieval Europe, the remains of extinct mammals were sometimes mistaken for the bones of biblical monsters. They were relics, symbols, mysteries, but not yet science. It would take centuries before anyone realized what they truly were. The birth of paleontology, the first steps, came slowly during the Age of Enlightenment, as people began to question and measure the natural world. In the 1600s and 1700s, fossilized shells found high in mountains puzzled scholars. How could sea creatures be buried in stone, far from the ocean? Some suggested great floods. Others thought they were tricks of nature. But as more bones were uncovered, patterns began to emerge. Strange teeth and claws, enormous limbs, shapes. Unlike any living animal by the early 1800s, scientists in Europe, especially in England, began to take fossil discovery seriously. One of the earliest discoveries, a creature with a massive jaw and strange teeth. The first dinosaurs revealed Megalosaurus in 1824. A British geologist named William Buckland published the first formal description of a dinosaur fossil, Megalosaurus, the great lizard. It was just a jawbone, but it hinted at something large, reptilian, and ancient. Iguanodon soon after. Gideon Mantell, a country doctor and fossil hunter, discovered enormous teeth in a pile of rocks in Sussex. They looked like the teeth of an iguana, but far, far larger. He named it Iguanodon, iguanatooth. Mantell and Buckland didn't know what they were looking at. Not exactly. They imagined dinosaurs as giant lizards dragging their bellies on the ground. But something was stirring. Something ancient, sleeping in the rocks, was beginning to speak. A new word, dinosaur, in 1842. A British anatomist named Sir Richard Owen brought these discoveries together. He realized these giant reptiles shared certain traits: strong hips, upright limbs, terrestrial, not marine. He coined a new term, dinosauria, terrible lizards, but Owen's idea of dinosaurs was still primitive, slow, cold-blooded, lumbering monsters. Still, the world was captivated. Soon, dinosaur bones were being unearthed across Europe. Museums began to showcase skeletons, and children imagined the earth, once full of dragons. They weren't far off. The Bone Wars then came America, and a fossil frenzy like no other in the late 1800s. Two paleontologists, Edward Drinker Cope and Othniel Charles Marsh, began a bitter rivalry. Each raced to outdiscover the other. Exploring the fossil-rich plains of the western United States, they hired dig teams, bribed workers, sabotaged digs, even destroyed bones they couldn't recover. But in their chaos, they uncovered Stegosaurus, Apatosaurus, Diplodocus, Allosaurus, and over 130 new species of prehistoric life. They fought. They fell from grace. But they changed paleontology forever. The dinosaurs were no longer a curiosity. They were a scientific obsession, a world beneath our feet today. Fossils have been found on every continent, even Antarctica. From the badlands of Mongolia to the deserts of Argentina, to the limestone beds of Germany, the earth is layered with memory. Fossils form only under rare, perfect conditions. A quick burial in mud, ash, or sediment pressure over time, the replacement of organic material with minerals. What's left is stone memory. A sculpture made by time itself, and with each new fossil, we see more clearly feathers on raptors, color pigments in ancient skin nesting sites and migration trails, even fossilized footprints and dung. The past isn't gone. It's right beneath us. New tools, new questions in the 20th and 21st centuries. Our tools changed everything. CT scans let us peer inside fossilized skulls and see brain cavities. Isotope analysis tells us what dinosaurs ate and how they grew. Fossilized soft tissue, including blood vessels and proteins, has been discovered. Computer simulations model dinosaur movement, balance, and behavior. And recently, scientists have begun decoding DNA fragments in ancient remains. We now know some dinosaurs had brightly colored feathers. Many nested and cared for their young. Some moved in herds. Others alone. They weren't slow. Some could run, swim, or glide. Many were warm-blooded, active, intelligent creatures. The more we learn, the more real they become. Dinosaurs today, over 10. 0 species of birds live today. From the tiny hummingbird to the towering ostrich, they are direct descendants of dinosaurs, evolved over millions of years, shaped by flight and climate and chance. When you hear a bird sing, you're hearing a voice from prehistory. When you watch them care for their young, you're seeing behaviors once thought impossible in reptiles. In a sense, dinosaurs never really left. They simply changed. And so the Earth whispers now, as you lie back. Picture the Earth, 150 million years ago. A vast plain under a double rainbow, a long-necked sauropod reaching for the highest leaves, a feathered raptor. Watching from the shadows, pterosaurs gliding on warm updrafts over a shallow sea. And now, that same Earth today. Hills that once held forests, cliffs built from old seabed stones that once were bone wind whispering over fossil beds. The story of the dinosaurs was never lost. It was simply buried, waiting, watching, until someone picked up a rock and asked, "What is this?" In the next chapter, we'll explore the biggest myths about dinosaurs and the incredible truths hidden behind the stories. The truth is stranger than fiction. Dinosaurs have captured the human imagination for centuries. They've been cast as monsters, as dragons, as roaring giants with razor teeth, as slow, dull beasts lumbering across ancient plains. But reality, as it often does, tells a much deeper, stranger, and far more beautiful story. In this chapter, we'll unravel the biggest myths, explore some of the most common misunderstandings, and reveal the astonishing truths that scientists have uncovered. So, settle in, let go of what you think you know, and journey into the mind-blowing world of real dinosaurs. Myth 1. All dinosaurs were giant, scaly monsters. When most people hear the word dinosaur, they picture something massive, like a Tyrannosaurus rex or a Brontosaurus. But in truth, many dinosaurs were small, some the size of chickens, some were feathered, not scaly, some could glide, dig, or climb trees. The smallest known dinosaur, a creature called Oculodentavis, smaller than a hummingbird. The diversity of dinosaurs is mind-blowing. Two-legged sprinters, long-necked browsers, armored tanks, horned, crested, spiked, or feathered forms. Dinosaurs were not just giants. They were every shape life could imagine. Myth 2. Dinosaurs had no feathers. For over a century, dinosaurs were portrayed as reptilian and scaly, like oversized crocodiles. But then, fossils began telling a new story. In the 1990s, paleontologists in China's Liaoning province discovered perfectly preserved fossils of small theropod dinosaurs covered in feathers. Now we know many raptors, like velociraptor, had feathers. Some species had wing-like structures. Feathers likely evolved before flight, possibly for warmth, display, or protection. Yes, birds are living dinosaurs. And the more we learn, the more we see that feathers were common. Not rare. Imagine a velociraptor, not scaly and grey, but covered in plumes of color, alive, alert, intelligent. Myth 3. Dinosaurs lived in hot, steamy jungles. Only it's easy to picture dinosaurs in tropical swamps and volcanic valleys, but fossils show they lived everywhere, even in cold, snowy climates. Fossils have been found in Alaska, Antarctica, and Siberia. Some dinosaurs may have had feathers or fat layers to stay warm. Others likely migrated seasonally. Just like modern animals, Earth in the Mesozoic wasn't all jungle. It had forests, deserts, mountains, and even icy poles. Dinosaurs were adaptable. They lived in environments we never imagined. Myth 4. The T-Rex was the biggest predator. Tyrannosaurus rex is iconic, massive, powerful, and terrifying. But was it the biggest predator ever? Not quite. Others may have rivaled or surpassed it. Spinosaurus aegyptiacus, longer than T-Rex, with a crocodile-like snout and a massive sail. Giganotosaurus, a South American predator that may have been heavier than T-Rex. Carcharodon, another giant theropod from Africa's T. Rex was unique, a bite force stronger than any known land animal, a skull built like a bone-crushing machine, keen senses, and a massive brain for its size. It may not have been the biggest, but it was one of the most powerful predators the world has ever seen. Myth 5. Dinosaurs are all extinct. This one surprises many people. But dinosaurs are still here. They just evolved into birds, from robins and crows to ostriches and flamingos. These creatures are the last surviving dinosaurs. Scientists can trace the evolution, step by step: hollow bones, wishbones, feathers, nesting behaviors, air sacs in the lungs. All signs point to one thing: birds are dinosaurs. When you hear a songbird, you're hearing the call of a creature whose ancestors once walked beside T-Rex. Myth 6. We know exactly what dinosaurs looked like for decades. Artists guessed dinosaur appearances based on bones alone. That led to some wild interpretations. Dragons with scaly skin, lizards with dragging tails, tyrannosaurs standing upright like kangaroos. But now, with modern techniques, we're closer to the truth. Skin impressions show textures and scales. Feather fossils reveal plumage and structure. Pigment cells trapped in fossils hint at actual colors. We've learned some dinosaurs were brightly colored, others were camouflaged. Some may have had stripes, crests, or glowing eyes in the dark. We may never know exactly what they looked like, but we're closer than ever. Mind-blowing fact: dinosaurs had super senses. Some dinosaurs had senses far beyond ours. T-Rex could likely smell prey miles away. Raptors had depth vision and could track movement like a hawk. Some had excellent hearing, tuned to low-frequency sounds. Their brains were often specialized. Some had massive olfactory bulbs for scent. Others had inner ear structures similar to modern birds. They weren't mindless monsters. Many dinosaurs were alert, curious, and sharp. Mind-blowing fact: dinosaurs lived for an unbelievably long time. The age of dinosaurs, the Mesozoic era, lasted over 160 million years. For comparison, humans have been around for less than 1 million years. All of recorded history fits into just 5,000 years. Dinosaurs ruled the earth for longer than mammals have even existed. And they didn't just survive, they thrived, adapted, and evolved across 3 entire geological periods. To them, we would be the fleeting ones. A blink in time, mind-blowing fact. New dinosaurs are still being discovered even now. In the 21st century, dozens of new dinosaur species are discovered every single year. Paleontology is still growing. Hidden fossils in South America, Asia, and Africa, advanced scanning revealing new details in old bones. Digs that unearth not just bones, but footprints, eggs, and even skin. The dinosaur story isn't finished. We're still writing it. And somewhere beneath sand or snow or stone, the next dinosaur waits to be found. Letting go of the myths now as you drift into rest. Let these truths echo gently in your mind. Dinosaurs weren't monsters. They were animals, majestic, bizarre, elegant, strange. They nurtured their young, fought for survival, sang, hunted, nested, and dreamed. Some had feathers like peacocks. Others stomped like elephants. A few soared, a few swam, and many left their footprints in ancient mud. The real story of dinosaurs is more beautiful, more complicated, and more surprising than anything fiction ever created. And there is still so much to learn. In the next chapter, we'll visit the lost worlds of the past, the actual ancient ecosystems dinosaurs lived in, from steamy forests to frozen poles, and deserts full of giants. Before roads, before cities, there were worlds untouched. Imagine opening your eyes and seeing a world without people. No buildings, no lights, no fences, just wind, water, trees, and creatures unlike anything we know. To understand the dinosaurs, we must go deeper than bones. We must visit their worlds, because they didn't live in isolation. They were part of complex ecosystems, each more strange and beautiful than the last. From swamps and deserts to polar forests and volcanic islands, each landscape shaped the lives of the dinosaurs who called it home. Let's journey now into those lost worlds, to see not just the dinosaurs, but the world around them, the Morrison Formation, a Jurassic jauntland where western United States, when 150 million years ago, late Jurassic. If you could stand in the middle of the Morrison Formation during the Jurassic, you'd see vast floodplains stretching to the horizon, towering conifers and ferns, slow, meandering rivers and herds of enormous sauropods moving through the trees like ships on a sea of green. This was the home of Apatosaurus diplodocus, Brachiosaurus, Stegosaurus, and predators like Allosaurus and Torvosaurus. It was a land of giants. Thunder rumbled not from the sky, but from the footsteps of dinosaurs the size of apartment buildings, the Gobi Desert bones in the sand, where Mongolia and China, when 80 to 90 million years ago, late Cretaceous today. The Gobi Desert is dry and windswept, but in the time of the dinosaurs, it was a shifting landscape of dunes, oases, and storms. Here lived some of the most bizarre creatures ever discovered. Velociraptor, small and feathered, hunting in the shadows. Protoceratops, a horned herbivore that nested in colonies. Oviraptor, once thought to be an egg thief, now known as a devoted parent. Therizinosaurus, with giant claws over 3 feet long and a body covered in downy feathers. Fossils in this region are often found locked in combat, frozen in time by sandstorms. The desert held life and took it back just as quickly. The Western Interior Seaway, an ocean in the middle of North America where, stretching from the Gulf of Mexico to the Arctic, when 100 to 70 million years ago, mid-late Cretaceous, imagine North America split in two. An enormous inland sea covering what is now Kansas, Nebraska, and much of the Midwest. Here, dinosaurs ruled the land nearby, but the water belonged to marine reptiles. Below the surface swam Mosasaurus, the 50-foot apex predator, Elasmus, with its impossibly long neck, giant sea turtles, fish, ammonites, and squid-like creatures above. Pteranodons soared, some with wingspans over 20 feet. This was a world where the line between air, land, and sea blurred, and danger could strike from any direction. Antarctica, the frozen forests where, Antarctica, when 100 million years ago, Cretaceous today, Antarctica is locked in ice. But during the Cretaceous, it was a lush, forested land, though still cold and dark for months at a time. Here, hardy dinosaurs adapted to strange light cycles and chilly weather. Lilanus, a small herbivore with huge eyes for seeing in the dark Antarctopelta, one of the only known ankylosaurs from the continent pterosaurs, birds and early mammals hiding in the trees. Scientists still puzzle over how these dinosaurs survived the long polar nights. Did they hibernate? Did they migrate? Whatever the answer, they were survivors of a land unlike any other. Islands of fire, volcanic worlds of the late Cretaceous, where modern-day Romania, India, and island chains in the ancient Tethys Ocean when 70 to 65 million years ago some dinosaurs lived not in vast plains, but on islands surrounded by water, volcanoes, and isolation in what's now Romania. The so-called island dwarfs evolved, smaller versions of giant dinosaurs, like Megasaurus, a mini sauropod, strange predators like Belosaur, with double claws and bird-like posturon. These islands' resources were scarce. Being big was a disadvantage. So evolution shrunk what had once been giants. This is known as insular dwarfism, and it happened across the globe. A reminder that even dinosaurs obeyed the rules of nature. The Hell Creek Formation, the last world of the dinosaurs, where North America, when 66 million years ago, end of the Cretaceous, this was the final chapter of the dinosaurs. A rich, vibrant ecosystem full of life, moments before it all changed. Here lived Tyrannosaurus rex, stalking the edges of forests, Triceratops, grazing in herds, ankylosaurs, armored and low to the ground, early flowering plants, beetles, and songbirds. It was not a dying world. It was a thriving one. And then it ended the day the sky fell 66 million years ago. A mountain-sized asteroid struck the Earth near what is now the Yucatan Peninsula. The impact was catastrophic. A fireball brighter than the sun's shockwaves that flattened forests for thousands of miles, tsunamis that swept continents, a dust cloud that blocked sunlight for months, maybe years. Temperatures plummeted, plants died, and ecosystems collapsed. Around 75% of all species on Earth went extinct. The age of the dinosaurs, the giants of the Mesozoic, was over. But not all life ended. Some birds survived. Some mammals hid and emerged. Life, as always, found a way forward. What made these worlds special? Each of these prehistoric worlds had its own story, its own rhythm, its own cast of characters. What makes dinosaur ecosystems so fascinating is not just the dinosaurs themselves, but how they fit into a bigger picture. Predator and prey, climate and vegetation, continental drift and sea level, rise, volcanic eruptions, and asteroid impacts. Dinosaurs weren't just visitors to Earth, they shaped it. Their footsteps dug into the mud, their dung fertilized the land, their herds changed forests, Their deaths fed new life. They weren't just part of the world. They were the world. And now the world sleeps today. Those ancient lands lie hidden under cities beneath oceans, within mountains trapped in stone. But if you listen closely, in the rustle of leaves, in the call of birds, in the sweep of stars, you can still hear echoes of those lost worlds. The earth remembers, and now so do you.